All right, so 8.7 is pretty short. It's really just using these formulas here, product to sum and sum to product. So let's write down all the product to sum formulas, and then we'll do the other way. All right, so here is the product to sum. Sine alpha, sine beta is equal to 1/2 times cosine alpha minus beta minus cosine alpha plus beta. The number 2. Cosine alpha times cosine beta is equal to 1/2. So it'd be almost the same, except you have a minus in the middle. So same thing. Sorry, instead of a minus, you have a plus. There you go. Number 3. Sine alpha cosine beta is equal to 1/2 sine alpha plus beta plus sine alpha minus beta. So those are the 3 product to sum formulas. So either you have 2 sines to cosines, or you have a combination of sine and cosine. If it's written the other way, cosine sine, that is the same thing as number 3. You just swap it, right? Sum to product. So going the other direction. Sine alpha plus sine beta is equal to 2 sine alpha plus beta over 2 times cosine alpha minus beta over 2. Sine alpha minus sine beta is equal to 2 sine of alpha minus beta over 2 times cosine alpha plus beta over 2. This is negative 2. So when you have cosine minus cosine, you're going to have negative 2 sine alpha plus beta over 2 times sine alpha minus beta over 2. Okay, double check everything before we move on. cosine plus cosine minus cosine. That's right. Sine plus sine. That is correct. Sine minus sine. Yeah. Sine minus sine plus. Hold on a second. Yeah, that's fine. Sorry, I got paranoid. 2 sine cosine. Yep. Yeah, okay. I'm missing one more though. The plus sign. Cosine plus cosine. That will be equal to negative 2 sine alpha plus beta over 2 times, let me see, plus minus plus plus. No, sorry, this is plus. Two cosine of alpha plus beta over 2. There we go. Times cosine of alpha minus beta over 2. There we go. Sorry. It's throwing me off a little bit. I don't know why I wrote that so ugly though.
With the sum to product, you always multiply by cosine of alpha minus beta over 2?
For the sum to product, you said?
Yeah.
Yeah, the arguments will be similar. These will change depending on what this is.
Okay.
What was I doing? But they're not quite the same. See how they differ a little bit? Like this one has sine cosine, this has sine cosine, but when they're both cosines, then it changes. So if it's a minus, then they're both sine. If it's a plus, they're both cosine. So the cosines are a little different. Okay. Yeah. Okay, so those are all the formulas we need for 8.7. Let's go ahead and start doing the first examples. They're actually only going to do a couple and then move on to the review because you're going to see all it is using the formula. And then we'll do more examples for these formulas during the review. So find the exact value of sine sine 285 times cosine 15. Okay, so what do you guys think we should use?
Sine A, cosine B.
Yeah, sine A, cosine B. So we'll do product to sum and hope they add up and subtract to something useful, right? Because 285 is not on the circle, correct? So let's go ahead and do it. So that'll be number 3. So sine of 285 cosine of 15 is equal to 1/2 times, so this will be my alpha, this will be my beta. So it'll be sine of 285 plus 15. These are all degrees. Plus sine of 285 degrees minus 15. So 285 plus 15, that's 300, right? Plus sine of 285 minus 15, that will be what? 270, is that right? So hopefully these are on our circle. You can go ahead and open the circle up. Yeah, they're both there. So here's 300. Here's 270. So sine of 300 is this guy, the y value. So that would be negative square root 3 over 2 plus a negative 1, right? And that's what it says there. The y value for 270 for sine is this guy. So at this point, just subtract these. We'll need a common denominator. So that will be negative square root 3 over 2. This is a 1, so multiply top and bottom by 2, which would give us 2 over 2. Combine that fraction and you get negative square root 3 minus 2 over 2, which is going to be negative square root 3 minus 2 over 4. That's as far as you can go doing fractions in algebra. But you can see all we're doing is using a formula, right?
So a real quick question about that process where it's sine 300 plus sine 270. In the future, if we have something that's like, I mean, could you add that to where it's sine 570?
Oh, you're 570. You mean like if it was greater than 300, 360?
Right. So I mean, like, let's say it was less than 360. Let's say like sine 300 didn't mean anything and sine 270 wasn't anything, but we add them together and that does equal to something on our circle. Would that be something we can do? Like, basically, could we add those two together?
You cannot add these because they're not considered to be the same.
Okay, just want to make sure.
You could apply sum to product. That's the only thing you can do, because here you have two different angles adding together. You could do this.
Oh, okay, yeah, that would be a completely different thing. Yep, okay, that makes sense.
But yeah, you can't add the middle. It's kind of like saying, what's it called? It's like if you had square root 2x plus square root 5x. I'm like, I wish that was 7x, but I can't because these are arguments. So I cannot add them.
Cool. All right, just want to make sure.
Yeah, no, it's a good question. Thank you for asking. You guys have any other questions on number 1? Is it all right? Okay. So it's not too bad, right? Just use a formula and be careful with your algebra and it should come out. So we'll do one more and then we'll move on to the review. To find the exact value of cosine 360 minus cosine 240. So we can't subtract the insides. All we can do is apply one of the sums of products. So let's use number, the one with, I forgot what number that was. Number 6. So this is my alpha and beta. So this would become, applying the formula, -2 sine 360 minus 240 over 2 times sine of 3. Actually, this should be plus, yeah. This one's minus. So 360 plus 240, what is that going to be?
600.
600. So that'd be 600 over 2 times 360 minus 240. That will be what? 120, is that right? So at that point, we get -2 sine of 300 times sine of 60. So just look at our circle. These are all degrees this whole time.
Real quick, what number did you say we were using in the formulas?
This one, I think I wrote on number, let's look at them just to be careful, right? So in our question, we had cosine minus cosine. So let's look at the one that has cosine minus cosine. That's number 6.
Oh, okay, now I see it. Thank you.
Yeah. So just apply the formula. Once you're done, you use the circle to help you out. That'll be pretty much 90% of the questions for 8.7. So let's see. Sine of 300. It's right there. Did that earlier. So -2 times negative square root 3 over 2 times sine of 60 is square root 3 over 2. Okay. All right. Okay, so square root 3 times square root 3 is going to be a 3, right? Because that would be square root 9 square rooted. Negative times negative means it's positive, so this entire thing will be positive. So we'll have these 2's canceling. 3 times 3, that'll be, I'm going to show the work so you see why. Square root 3 times square root 3 is in square root 9. Negatives are gone, giving us 3 halves. Is there any questions on number 2? Okay, let's start the review then. Review for test 2. We haven't done this review, correct? I can't remember. Pretty sure we haven't. Okay. So here is exam 2 review. So the first one is basically just using the property of sine inverse or your unit circle. 3, 4, etc. I think are more of calculator questions. So let's do the first one here. Okay, let's go to another page. Okay. So number 1, find the exact value of sine inverse of square root 7, square root 2 over 2. So you can just use the definition, or you technically could use a circle, but it's better to use a definition or understand what this means, right? Definition says that this means that there exists a theta that will equal to square root 2 over 2, right? That theta would be pi over 4 by looking at the circle. So once you change it, you can kind of see like, oh yeah, this happens here, right? The y value, there's an angle that gives me this y value. That's what this is saying. What is the angle? Well, this. That's what this means. Okay. Now let's move on to number 4. You guys have any questions on number 1?
So that's by looking at our notes.
By looking at the definition and the circle, right? So when you see sine inverse of some value, this value happens where? Right, so we look at the circle here. I get a y value of square root 2 over 2 at pi over 4, or 45 degrees, either, whatever. Same thing. And that's what that's saying. Where does this happen? That's what inverses do. They do the opposite. So the definition was, this was in the notes. There's a definition where you can rewrite any inverse like this.
But wouldn't that also occur at 3 pi over 4?
Yes. Yeah, it would. Let me look at this. 3 pi over 4. It would, but sine inverse is only defined on the right side of the circle. The domain and ranges for the inverse functions, you'll make sure you have those with you. But if we look at the question, yeah, you would. The answer would be pi over 4, and because of that reason. But if it would have said find all values, And if it was like an equation, then yeah, that'd be different. But since they just give you this here, then use the property of inverses. Okay. Look for the 1 second. Okay. Where's number 4? All right. Find the inverse function. So here we're going to go over how we find the inverse function for a trig function. So I'll go over the steps like we did on the examples to remind you. So find the inverse function f inverse of the function f. F of x is equal to 5 cosine of x plus 9. All right, so step 1. Change f of x into y. Step 2, swap x and y. Step 3, solve for y using inverse functions. So we're going to subtract the 9 over, and then divide by 5, and then we introduce the inverse functions. So isolate cosine y. So minus 9, divide by 5. So now, all we have to do is get rid of cosine, and we've solved for y, right? I'm going to put cosine on this side just because it makes me feel good, not because it matters. So I'm going to do cosine inverse of both sides in order to cancel the cosine. So these will go undo each other. So you're left with y equal to cosine inverse of this guy. Any questions on this example? Is it okay?
That would be the final answer.
Yeah, that would be it. The only extra step would be to replace this for f inverse. See, let me show you. See how they have f inverse equals this?
Yeah.
Because that's what we're solving for, is the
Yeah.
inverse. So just relabel that technically. Any questions on any of the steps?
So the way you write these out is the way you would want it written out on the test, right?
Yeah, I mean, you don't have to write the steps, but
Just the
yeah,
work.
this-
Okay.
yeah, I would like to see as much work as you can show me. All right. All right, let's do number 5. You guys have any more questions on 4? The algebra okay, the process makes sense.
I don't have a question about number 4, but the ones that require calculator, would you still just show us just to make sure that we understand how to do it in the calculator?
Sure, yeah. Let's see, number 2. Let me grab my calculator. Okay, so you just punch it in like this. You do 10 inverse, and then you put 0.7 for number 2. And then you round to 2 decimal places, which would be 0.61.
Jack, for that one, should it be in radians or degrees?
Radians. Since you don't see the degree symbol on the question, you should assume radians.
Okay.
If they would have said 0.7 and then put the degree symbol, and none of the answers have degree symbols, so it's safe to assume radians.
And this test is just on chapter 8, correct?
Right, just chapter 8.
Okay.
Should be similar to the review we're doing.
Okay, and then we are meeting Thursday, but the review's due Sunday and the test is due Wednesday, right?
Right. So Monday and maybe Wednesday, Thursday. I'm sorry, Tuesday, or maybe Tuesday. Probably start chapter 9. Thursday, I'll review some more if you need it, but I might start chapter 9 at that point.
I'm gonna go then, if you don't mind, if that's okay.
No, as long as you feel confident.
I don't, but I have something I have to take care of.
No, I understand. I understand, man. No worries.
Thanks.
See you later. What number is this? Number 5, right?
Yes.
All right, so this one says 4 cosine inverse of x equal to pi. So if you isolate the cosine inverse by dividing by 4, right? You get cosine inverse of x equal to pi over 4. Now, if we use a definition, we can say this is the same as asking what x value would be given for the angle of pi over 4 for cosine.
Square root of 2/2.
Yeah, so x would be square root 2/2 using the unit circle. Which I think is B, answer B. Number 6. Is there any questions on 5? Just make sure you write down the definitions on your formula sheet. Find the exact value of tangent inverse Actually, it's just regular tangent. Of cosine inverse of negative 1/2. So we did a couple of these in the beginning of chapter 8. We have to build a triangle. So what we do is say, so given this guy, so basically we need to find tangent given this inverse function inside. So let theta equal to cosine inverse of negative 1/2. Yeah. So that's tangent of some big funky theta. That's what I'm saying right here. See what I mean? Apply a definition here. So that would mean that so by definition, that means that there exists a theta for cosine that would equal to a value of negative 1/2. So use this to build a triangle and then find tangent. That's what we're looking for. Ouch. So hypotenuse is 2, adjacent is negative 1. Do your Pythagorean theorem and you'll get a square root 3 here. Let's skip that step there. Now, let me look at the question real quick. I think that's all they gave us. Yeah, so tangent is opposite over adjacent, right? So opposite over adjacent, so that would be equal to square root 3 over negative 1, which is negative square root 3. So that would be your answer. So use the inside part to create the triangle, and then answer the question, what is tangent? That's all you have to do. Any questions on number 6? Number 7, find the exact value. Exact value of cosecant inverse of negative 2. So there's a property that says you can rewrite this, because cosecant is technically 1 over sine, right? But there's another property that says cosecant of negative 2 is equal to sine inverse of the reciprocal of the argument. So cosecant of negative 2 is equal to sine inverse of negative 1/2. So you just flip it over. So now taking the inverse range into account, the range of the inverse function, where is sine inverse? Where would this be true? What is the angle?
$330.
330. But since it's out, that would be outside the inverse range. How would you get to 300 going in the negative direction?
Oh, negative 30.
Yeah, so you'd have to use negative 30. Or they have it all in radians, so you would say negative pi over 6 for their answer choice. Just answer B. So make sure you have all the range and domains on your formula sheet. Any questions on 7? Is that straightforward? Number 8, use a calculator to find the expression in radians. So cotangent inverse of 10 over 29. So you can use the same property we used before. So the reciprocal would be tangent of 29 over 10. Inverse still though. So use your calculator, you should get about 1.24. Give me one moment. If this is on a circle, then to find the other angle, you would do 180 minus 30. So these are my two angles. So the answer would be that theta is equal to 30 degrees, comma 150. Or they might have it in radians, but pi over 6, 5 pi over 6.
Okay, so real quick, so you said that if it wasn't on the circle, that we would do 180 minus 30?
180 minus this value, like for example, the way you would find this, right? Let me show an extra step. You would have to do sine inverse of both sides to solve for theta, right? So if it wasn't on the circle, you have to do this. So this would cancel, giving me the theta. So sine inverse of 1/2, the calculator is going to give you 30 degrees. Once you have that, to find the other one, let's say they gave you like 29.4 or like, I don't know, 5.7. To find the other angle, you'd have to do this.
Okay, yeah, I got my notes mixed up.
Okay.
So we did not have to do any of that because it was on the angle. I mean, on the circle or whatever.
Yeah, right. The distance is a value we've been working with on the circle. We didn't have to show this, but let's look at another one where you don't have that. On number 11, it says use a calculator to solve the equation on 0 to 2 pi so here we go. So tangent of theta is equal to 4.8 radians. So you have to do tangent inverse of both sides to cancel the tangent to find the theta. So theta would be equal to approximately, the calculator would give us, let me see, 1.37. To find the, but if you're doing a tangent, to find the other one, you'd have to do 1.37 plus pi. Instead of doing minus 180 minus that, tangent is a little different because of the domain and range is different. The period is different. So that would be approximately 4.51. So you have these two answers. Okay. Any questions on 10 or 11? Is that clear? Let's move on to there'll be a couple of proofs on the exam where you got to show every step. So let's start doing those. Let's go to 14. 14, they don't tell you to prove just yet, but they want you to simplify it. So it's like the step right before proving things. So cosine theta plus, or over 1 plus sine plus tangent. All right, so simplify meaning just add the fractions, see what cancels, and that's it. So right now, tangent can be rewritten as a fraction, right? As a quotient. Because we know that's supposed to be sine theta over cosine theta. So that's just using the quotient property. So add these two fractions, so you have to introduce the LCD. Since the denominator is prime for both of them, the LCD has to be the product of both denominators. So LCD has to be 1 plus sine theta times cosine theta. So this one needs the cosine, this one needs a 1 plus sine. So here we go. I'll multiply top and bottom by cosine. And then for this one, I'll multiply the top and bottom by 1 plus sine theta. Okay, so the top part will become cosine squared, right? Cosine times cosine plus sine theta plus sine squared theta over the LCD. So up here, all I do is multiply this across, right? Sine times 1, sine times sine. So now bring it all together, add them together, you'll have cosine squared theta plus sine theta plus sine squared theta over this LCD. So cosine squared plus sine squared. So all this was just adding fractions, by the way. So cosine squared plus sine squared, we know that should be 1, right? So from here to here, we did Pythagorean identity. Because cosine squared plus sine squared is 1. But now notice you have 1 plus sine and 1 plus sine on top. So these will cancel, leaving you with 1 over cosine, which is really a secant. So that's as simplified as you can make it. So when they say simplify, this is what they mean. Just combine stuff, see what cancels, and then leave it alone.
And you're gonna want to see like that on the sides, reciprocal property, Pythagorean identity.
You don't
as
have to, but as long as you show, I mean, I'll know what you're using. But this will be helpful for me, but you don't have to. As long as you show like your individual steps, it'll be good. The more steps, the better. So I can, if you mess something up, I can at least help you out.
I have a quick question.
Mm-hmm.
How did you get that 1 plus sine on the third to the last?
Yeah, here.
Yes.
So this sign was right there, right?
Mhm.
That's this one. So cosine squared plus sine squared is always equal to 1. So I
Oh,
combine
okay.
these two here.
Okay, thank you.
So that's the Pythagorean identity right here.
And the answer that would be chosen would be secant theta.
For that one, let me see. Right. The final answer would be secant. Okay. Now let's do a proof type. Establish the identity. So whenever you hear that, they want you to prove it. Prove that it's equal. So secant theta minus 1 over tangent theta is equal to tangent theta over secant theta plus 1. So you choose a side. Doesn't matter which. On this one, they look pretty similar. So I'm just going to pick the one on the left, I guess. So I'm choosing this guy. And I'm going to try to get to the other side using all the properties we've learned. So one of the techniques is to multiply by the conjugate. So as soon as I see a -1, secant -1, I think, you know what, maybe if I multiply top and bottom by the +1 version, I can create something, some sort of identity to help me out. So I'm multiplying the top and bottom. So the top will turn into secant squared theta -1. The bottom, I'm going to leave it like this. I'm not going to multiply it out because sometimes leaving it this way will be more helpful when you want to cancel stuff. Okay, so top part multiplies this way. So if you do secant times secant, secant times 1, -1 times secant, -1 times 1, you'll end up with this. I'm going to skip that algebra step. So here we multiplied by conjugate. Now, there's a identity, right? Secant squared -1 is equal to tangent, right? Thank you. Yeah, that's right. I need to always double check. Tangent squared, right? So use the identity, and you'll be left with this. So from here to here, Pythagorean identity. That's what I used there. So it's tangent theta times secant plus 1. One of these tangents will cancel, leaving you with tangent theta over secant theta plus 1, which is what we wanted to show. Any questions on 15?
So our answer is basically showing like step by step to prove that it is that.
Right, right. So you're using all your properties that you've learned so on chapter 8 and chapter 7 to get to the other side. Also in chapter 8 though. There's a few from chapter 7, like for example, tangent equal to sine over cosine. That's from way back when, but it is chapter 7. All right, so I'm gonna stop here and let you guys try this review. Please try a couple of times, and then on Thursday, bring some questions, and we'll go over some more. And if you don't have any questions, then I'll assume you're good, and we'll start chapter 9. But please go over it because it'll make more sense if you try it.
Okay, thank you.
Thank you, Professor.
Right. I'll see you Thursday.